Molar conversions are done the same way conversions with atoms were done to molar. Okay, you may remember this. A little bit of review here. Here's the old stuff. Write this down. You're going to see how it fits right together with what we're going to learn today. We learned in chapter 3 or 4, I mean, it was a while ago. It wasn't the last 2 or 3 chapters. It was quite a while ago. We learned that 1 mole contains that number. What's that number called? Avogadro's number, right. Okay? 1 mole, you have that many atoms in there. We explained why. I explained why. I tried to. It probably wasn't completely clear with you. But if you wanted to know why, you can go back and look at that. But that's how many atoms are in a mole, the atomic mass in grams of a particular element. So if I have the atomic mass, that also equals that, right? So if I look at the periodic table, I can tell a few things just from the periodic table. All right? I know that 1 mole of carbon, for example, is going to weigh 12.011 grams, right? And I also know that's how many atoms it contains. So I can do conversions. Kind of like, what's different about this? What did we just learn on Friday? I know it was a weekend. I kind of like to do this the day after each other because if it were, you would remember that just yesterday, or just Friday, we basically did something called molar mass instead of atomic mass. So like, for example, if I had 1 mole of carbon, it weighed 12.01 grams. 1 mole of oxygen weighs 15.999. And 1 mole of carbon monoxide weighs the 2 of those together. And that's what you did your problems on Friday. All right? Well, here's my new, I did conversions with those back in the day, and I'm going to do conversions with these. I can convert from mass to atoms or moles, all right, moles, and I can also convert from mass now to moles and to molecules. Okay, so 1 mole in the new thing we're going to use molar mass. 1 mole still equals 6.022 times 10 to the 23rd, but it's not atoms. It's molecules, you see. I'll try to make that clear with you in a second, because sometimes people don't quite understand this. Okay? Which isn't called, what's that called then? If I have that many molecules of, say, carbon monoxide, it's not going to be the atomic mass, it's going to be the molar mass, yeah. All right? Now let me try to make that clear, because some people have trouble with that for some reason. Kind of think of it this way, okay? I'm just going to use a very simple, because a lot of people are like, they don't quite understand. How could I have 6.022 times 10 to the 23rd carbon atoms, okay? Okay, that's what I've got. 6.022 times 10 to the 23rd carbon atoms. And 6.022 times 10 to the 23rd oxygen atoms. And yet when I put them together, I don't have double that. Well, here's why. Watch. I have 1 carbon atom. I have 1 oxygen atom. When I put them together, how many carbon monoxides do I have? 1. 1 plus 1 is 1. That's why we're able to use the same number. Because we're not talking about how many atoms anymore. We're talking about how many molecules. Again, 1 carbon plus 1 oxygen equals 1 carbon monoxide. So 10 carbons plus 10 oxygens would equal 10 carbon monoxides. And 6.022 times 10 to the 23rd atoms of carbon and 6.022 times 10 to the 23rd atoms of oxygen would give you 6.022 times 10 to the 23rd molecules of carbon monoxide. You see? Make sense? That's why we're able to do these calculations exactly the same way we did them back in chapter 3 or 4, using exactly the same numbers. 1, this number, and whatever the atomic mass is, although it won't be the atomic mass. What will it be? The molar mass. You have to add them together, whatever that molar mass is. So let's do 2 examples, and we'll be done. We may only have 1 example. So that's basically, I mean, you already read it again. That's basically what I'm going to write up here. Underneath here, this board over here usually contains throughout the chapter stuff I like to leave up there so you can just look at it. It's not there in the data test usually, but I'll put that up here in a little bit. Okay, let's do our examples. Try that one. I'll do 2 examples here, and my guess is you'll be able to get it from 2 examples pretty easily. I'll let you work on, for the second half of this period, some problems on it, and then next period we have a lab. Nice. Let me show you. Let's just go way, way back. Let's go to the way, way back machine. Here, you ready? the way back machine. What if this said, determine if I had 2.5 grams and I wanted to convert it to milligrams? Remember, that's what I first told you about conversions. Grams to milligrams, centimeters to meters, right? That's what I first told you about it. What would you have done? What do I write down first for any of those problems?
Times.
No, I don't write times. I write what? I write the given. 2. Sorry. I write 2.50 moles. I write the given down, correct? Now, I multiply by what units have to go on the bottom? Moles of that lithium fluoride. Now on top, what are we looking for here? What is it asking me for? That's for mass. So it doesn't specifically say what the units are, but what are the units of mass? Grams. So I put a gram up there, G up there. And then I simply go back and I remember what this says. What's in that box a minute ago? 1 mole equals 6.022 times 10 to the 23rd atoms, or molecules in this case, equals the molar mass. And that was what was in the box, and that's what we're going to use. What goes next to moles every single time? 1. Just 1. Not 1 point anything, because 1 is an exact counting number. I don't have to worry about significant figures for that guy. But I do have to worry about it for the mass. And here's the problem with this guy. Change one word, and I could have done this in chapter 3 or 4 whenever I did this. If I change this word, if I leave out fluoride, 2.5 moles of lithium, what would you write up there for next to the mass? You'd write 6.941, the mass of lithium. But because it's lithium fluoride, I have to worry about writing lithium fluoride correctly and then adding them up. What is lithium fluoride? Li plus 1, right? F, what is he? Minus 1. So is he written correctly like that? He is. So what do I have to do to write this mass in here? Is it going to be 6.941? Is it going to be 18.998? No. It's going to be those two guys added together, which is 25.939. You see where that came from? Does everybody see where that came from? It is simply the mass of Li and F added together. Because this time we're doing a molecule, not just an atom. Good. All right, get your calculator out, multiply that out, see what you get. You get some long number like that maybe on your calculator, right? We know we have to round that off. Where am I going to round that guy off to significant figure-wise? What do you think? What's my answer going to be? Multiplication and division, you round to the least number of what? Significant figures, not decimal places. So he has how many? 3. So he has to have that 3, and that will be the correct answer, 64.3. Got it? Or 0.8. Got it? All right, let's do one more. How can I make this more difficult, obviously? Instead of giving you LIF, I can give you a larger compound. I can also ask you for molecules instead, and I'll do that too. I'll put both of them together into an example where this is about as hard as it can get, and if you can do this one, you can do anything. Although I can ask these, you realize I can ask this. Take a look. I can give you moles and ask you for grams, like I did here. I can give you moles and ask you for molecules. I can give you molecules and ask you for grams. I can give you molecules and ask you for moles. I can give you grams and ask you for moles. I can give you grams and ask you for molecules. So I could ask it 6 different ways, right? Okay, so you have to keep that in mind. Let's do it this way. Nope. Try that one. Notice again, I am reviewing with you naming. You know, I said in the other class, I think I hadn't graded yours at this point. The other class, I gave that quiz, whatever you want to call it, open notebook, open book thing on Friday. And the other class, I said, oh, yeah, they did really well. Most of the grades were really high. Not so much for you guys. There were quite a few low. There were a lot of good grades, but there were several people who had really bad grades on that. Now, look, I'm not going to go back and reteach that. I don't have to, because every day I'm doing this. I did it on Friday. I just did it a second ago, and I'm going to do it again today. I'm going over these again. Let's go over how we name, because I can't do this problem if I don't have calcium chloride written correctly. How do I write? You need your common ion sheet in front of you. If you don't have it, get it out. How do I write calcium chloride correctly? Look at your common ion sheet. How are we going to do this? Because this is all review. Every day is review. It's not like I taught that. Oh, yeah, I was absent last Tuesday, so I'm okay. That's why I don't understand this. I didn't just teach it Tuesday. I taught it Tuesday, Wednesday, Thursday, Friday, and today, and tomorrow. I'm going to teach it every day. Calcium chloride. Symbol and charge for calcium. What do you think? +2. Everybody agrees +2 because it's in group 2. Now, chlorite, if we look at that ending, we know he's one of these guys over here. He's ternary. If he's ternary and he doesn't end in ATE, he's not right on the sheet there, right? Which one is he? Well, he's one less than the one on the sheet, as you can see from right over here. You got to use this on Friday. And I taught it to you on Wednesday and Thursday, whatever day I gave it to you. So what is chlorite on the sheet? He's ClO3. This guy's what? ClO2. One less than that. What's his charge? If you look on the sheet, his charge is -1. So I've got a +2 and I've got a -1. Correct formula for calcium chloride should be CaClO2 2. Got it? Good. All right. Why did I have to do that? Because I can't do the rest of the problem without that. All right. I got to start with that. Now let's set up the rest of the problem. What do I write down? What am I going to write down here? The given 248.9 grams, and start my conversion. What units are going to go on the bottom this time? Last time I was given moles. They went on the bottom. What goes on the bottom this time? Grams. And what am I looking for this time? Molecules. Not moles, but molecules. What goes next to molecules every single time? And if you don't remember, look over here. 6.022 times 10 to the 23rd. Just like it went next to atoms every single time. Back in the day. What goes next to grams? That's going to be a problem, isn't it? You can see it already, can't you? I got to have 1 calcium. How many chlorines? 2. How many oxygens? Can you try to do that in your head? No. Can you do it on a calculator all at once? Some of you can. What do I need to see for the problems? I need to see that chart. Okay, so let's make that chart. Same chart you had to make on Friday. The element underneath there. Element, the number of atoms, times the atomic mass. And then that giving you the total mass. And then you add those up. That way I see the work you did. What's the advantage of doing that? Well, number one advantage is you'll get the answer right more often. The other advantage, and probably the more important advantage for you, I'll give you a partial credit if you do it. And I'll take off points if you don't. Okay? How many calciums do I have? In that problem over here, I have 1 calcium. How many chlorines do I have? 2, not 1. You have to distribute the 2. And how many oxygens do I have? 4, because once again, I have to distribute the 2. 2 times 2 is 4. Does everybody see where 1, 2, and 4 come from? If you don't, you need to stop me. All right. 1 times 40.08 is 40.08. 2 times 35.453 is what, 70.906? Is that right? I think. And finally, 4 times 15.999, you'll have to do that on a calculator. Although it's not that hard. What is it going to be?
47.
4 times that?
No, 63.
63, I would think. 63 point what?
996.
996. That makes sense. Okay, do be careful. Now, that's the beauty of this. Say you accidentally did plug it in wrong, and you got the wrong number on your calculator. No big deal. You would only lose 1 point if you showed me all this work the way I'm showing it to you here. Add all those up. What do you get? 174.98. Let's see if we got the right number of significant figures. You should only have adding up significant figures. Decimal places take precedence. So 174.98 is the correct number of decimal places. I'm assuming you did the math right. Is that right? Everybody get that? Okay. Now, a lot of people say, okay, I'm done. And they forget, you're not done yet. Where does that number go? It goes up here. 174.98. Now you need a calculator. And hey, guess what we have to do again? Exponential notation on our calculators. Multiplying, then dividing by that number, especially you guys who have crafted those blue calculators. There's a couple of you in each class. All right, hopefully you remember how to do it because it is complicated. If you don't, if you want to borrow one of my calculators, you can for those kind. I don't care. But most of you guys know how to do it by now. What'd you get for an answer here? Hannah, what'd you get?
8.566 times 10 to the 23rd.
Did anybody else get 8.566 times 10 to the 23rd? Is that right? Wow, looks like everybody did. That's great. I mean, I'm assuming that's right, and I really don't care. Why don't I care? Because that's worth 1 point. How much is this whole problem worth? Probably about 10. All right, you're going to have, because part of that problem was doing this, and part of that problem was doing this. So maybe not 10, maybe 8 points this would be worth on the test. Okay. All right, good enough. It's only -1 if you get the wrong answer. Okay, your homework is up here. I